Hello, everyone. Hope everyone can hear me. Uh, Welcome to my simulation on a cold store of a warehouse, a cold warehouse, which we have conducted for a multinational FMCG company
Ali,
operating in Turkey. Hello?
can I just jump in there, Ali, one sec?
Sure,
I'm sorry.
sure.
Have you got the presentation shared?
I thought I did. Let me share it again.
Yeah, just give it one more go.
Okay. Can you see it?
Yeah, it's coming
Okay,
through. One sec.
okay, okay.
Excellent. Thank you, Ali. Sorry about that.
Sorry about that, Kevin. Okay. Uh, yes, this will be the presentation of the simulation of a cold store of a customer in Turkey, which is a leading multinational. And I will show you what we have done and what results we have achieved. And I think this is one of the typical applications of simulation, at least in Turkey, I would say, is warehouse operations and how you may optimize your resources within some constraints. Let me give you a brief introduction of what problem, what objective we had while we were doing this simulation. Uh, this is a store with some rules and constraints. One of the major and very critical constraints in a cold store is that it has to apply, we have to apply very strict FIFO rules because the products has to be fresh. They shouldn't wait too long in the warehouse because they are perishable. So this is a very important hard constraint. We had many depths in the racks, 6, 12, quite many depths, and all the depths of the product has to be the same product, otherwise things get too complicated. So we have to pay attention where we store the pallets and where we pick the pallets, considering these two rules. One other critical uh, critical constraint is that while you are this part of the warehouse is at some degrees Celsius. It's cold, minus several degrees of Celsius. Here, it is not that cold because people are working here with, with relatively usual clothing, and they have to conduct a task. So the loading has to take time, not longer than a specified minutes. Otherwise, the goods may get perished again here. So we have to pay attention to that as well. And of course, the loading area has a limited number of capacity that it can accommodate while loading and offloading the trucks. So within all these constraints, we were trying to find out the optimal resources, the forklifts, which travel between the racks, do the loading, uploading, and the collectors, the people, let me say, uh, who assemble mixed pallets here, which means you bring some pallets here, several pallets, and you make a new pallet, and you have to complete it in a certain amount of time. And we have runners. I will explain what this runner is. A runner is a machine which enables loading and offloading these depths of the racks. So this was the problem. It's not a, it's not a magic problem. It's not, I would say, artificial intelligence or machine learning or whatever. But it's a simple problem to come up with the optimum number of forklifts, collectors, and runners while meeting all these constraints. Um, there are some other stuff, some other things to consider in this kind of business. This is a very seasonal product. So in summer, you are selling too much, too many products. In winter, you are not selling so many products. So what happens is that at some times of the year, the customer wants to switch off some of the rack areas, like they want to switch off this part, because keeping it running needs energy, cost, people, so they have to just switch it off, forget it, and don't use it. and they have to see the consequences. Which of these they should switch off, which of these they should be using, and what would be the impact. Also, the dock usage was another, how should I say, parameter to play with for optimizing the resources. You may give a priority for inbound to some of the docks, or you may give a priority, or you may give to export products some priority. Moreover, you may assign the docks to trucks with this predefined priority here, or you may just let the system, let the simulation engine decide which load to assign to which truck, considering the distance and trying to minimize the travel distance of the forklifts and the collectors. So you could play with all these parameters here, which one to switch off, on, how to allocate the docks, how to decide which docks to allocate, and stuff like that. And of course, we had the morning shift and night shift resources. We could play with these and see the results, and come up with the best optimum setup. This color here, we use the palette color for a very specific heat map purpose. We could color the palettes for product type, so we could see which product type is at which rack. We could also color them by, for example, number of pickings takes place. So we could have the heat map of the warehouse. If it's darker here, oh, it means we are picking a lot from here. If it's lighter color here, oh, we are not picking so much from here. So we could see the operational heat map of the warehouse and make decisions about, oh, am I, storing this product in the right place? If it's moving too many times, why should I pick here, store it here, not here, here? So this gave us very useful information about the placement of the pallets in the warehouse. And finally, we use real data. We uploaded their a busy week, not so busy week, and we saw the results. But we could also generate random data. If we click this, for example, next year they may be growing their business, and the data we have uploaded may not be enough. So we could generate artificial random data using the real data and see how it would look like if I increased or decreased my production volume. So let me start with the resources and show you some screenshots of how the simulation ran and what results we got and what final decision we made. As I said, we had forklifts, collectors, runners, and transpallets. We decided to split the forklifts for dedicated tasks. So we had outbound forklifts, the red ones here, and yellow forklifts, the yellow ones here. And these runners are the machines also assigned to inbound operations and outbound operations. The runner operation works like this. This was also an analysis of how useful, how efficient was use of the runner. The runner works like this. The forklift picks a runner, and then they take it and place it in a rack. So this runner does, when you want to store a pallet in this rack, you just put it here, and the forklift can go away. It doesn't have to wait. The runner does the rest of the work. It just moves the pallet along the rack and comes back. This enables to free up the forklift to do some other tasks. So the forklift places the runner here on this rack, and then the pallets are stored by the rack itself, and the forklift goes and picks one another pallet and comes back and leaves it to runner and goes back. But to be able to do this, you have to batch your pallets, because these pallets, you should have enough pallets here to make an efficient use of this runner. Once you put this runner here, you would like to store at least, I don't know, 6, 5, 10 pallets there. Then you take the runner from this rack, you carry it somewhere else, and you put it somewhere else, and you keep feeding the rack using the runner. So all this batching here, finding the right rack here, putting the runner there, and feeding it required some logic behind it. And don't forget, you have limited space here. You cannot overload this space here. On the other hand, you have to have enough pallets here to make better use of runner. You don't want to do this. You don't want to put one runner here and then store one pallet and take the runner, move it again. No, you shouldn't do that. Once you put the runner here, you would like to store at least 5, 10 pallets to make good use of it. So this puts one more operational constraint on the process. We run the model, and of course we verified it with the real uploaded data. These are the number of number of pallets brought in by inbound trucks, brought in by inbound conveyor from the factory, and these are the number of pallets loaded to the trucks. And we checked, this is the current state. We checked that the model really does the job. We have loaded all the trucks, we have uploaded or offloaded all the trucks, and we have handled the pallets coming from the conveyor. And this is how we, orders received, orders delivered, and inbound trucks, and the number of pallets moved around, they all fit together. That's fine. This was a cross-check of we have delivered what they deliver in physical world. And then we looked at the utilizations, of course. This is what we are doing it for. And yeah, we had some room. The utilization of the docks, collectors, forklifts were somewhere around 60%, 65%, including some breaks. Since this is a cold store, people have to take very frequent breaks, long breaks, because they cannot stay in cold for more than several minutes, for more than 20 minutes. So we had some room here, and this scenario was their current scenario, 6 forklifts, 8 collectors, 6 runners. And of course we did some other statistics as well, besides just utilization, to cross-check. So how many pallets we load on one truck, how many pallets do we receive in one inbound truck, how many mixed pallets do we make, how many different types of products do we have in each mixed pallet on average, how many layers we build up in one pallet, all these to make sure that we are in line with the reality, just cross-check what they are doing, and this is reflecting the reality. And here we see this one critical thing, how many pallets we have at any instant of time waiting somewhere, at the inbound area, at the outbound area. Are we within the limits? Is this realistic or not? So this was a cross-check of what really we were saying was realistic or not. And of course, then we ran some scenarios. What we did is we reduced number of collectors and checked what happens. We reduced some runners. Where is the forklifts? Yeah, the forklifts, 5, 6, 4. And at some stage, we couldn't deliver. Something blew up. The pallets was, overflowing all over the place. But up to a point, we were able to, deliver everything we wanted to deliver. So that was fine. And this was discussed with customer. This was feasible. within all the constraints we had, yeah, we could perform with less resources. Why not? And then, yeah, we had these many outcomes of the scenario, and we said this is the best thing we can recommend you. It does everything you need, and the utilization goes up to about, I don't know, 70. Let me check here. Yeah, 70, from 50s to 70s and 60s. You may argue this is still low. I think it is still low, but there is a limit to what you can do, because you have to reserve some time for the breaks because of the cold environment, because of the tough environment. So this was it. This was it. We couldn't go any further. Yeah, that was how we did a simple work in several constraints and came up with a better and more efficient resource level for the customer. Now I will show you a few actions of this, let's say. I will not get into all the details because it will take time, and just show you how the work done. These guys here, you see, they are assembling a mixed palette. They are picking from several palettes alongside them, and they are putting them in this black palette, which is a mixed palette. These black ones are mixed palettes. And now these guys will come and load Yep. So warehouse simulation is nothing interesting. You have seen that many times. This is a warehouse, no different from any other. But the real interesting thing here, the real problem here was, the process behind it within all these challenging environmental temperature constraints, let me say. Let me show you how the start screen enables some different scenarios as well. Here you can switch off docks or switch off racks. And you may have runner racks, normal racks. You may store only some type of products in a rack. And yeah, you may make the palette colors by SKU group or by transaction volume to have the heat map. So this gives you many combinations of scenarios, which would take many hours to test in physical world. But this is just a few minutes of simulation time, and you see the effect of your scenario, of your warehouse structure in just a few minutes. So I think I have come to the end of my presentation, a couple of minutes earlier than planned, probably. Any questions, any comments?
Thank you, Ali. Yes, there's a question just come through asking about why didn't you use an optimization tool?
That's a good question. We could do that. We just, the parameters we were looking at were actually two things. One of them is the number of forklifts and number of collectors. So with that simple, two parameters, while reducing them, it was just easy, and we picked the simple and easy way. But we might use the optimization tool. That's a good question.
Mm-hmm. Okay. And do you have any further plans to develop this model?
Yes, we do actually. The heat map analysis, the placement of the pallets, we played with that around as well, but it didn't give any significant difference. Now the customer is thinking about automatical retrieving and retrieving systems, or AGVs. We couldn't have the time to model that. They are first talking to some vendors because not all AGVs can work in a cold environment. But once they have some ideas about these machines, we plan to model the AGV and the ASRS equipment.
It sounds like a good development. Got some comments coming in saying very cool model. And could you tell us if there were any specific slotting policies within the store?
Yes, actually, the slotting, we tried to use, of course, the slotting policy, but one problem, let me explain why it didn't promise too much improvement with this slide. Can you see my slide?
One moment. Yes.
Yes. Well, if you look at here, the most of the inbound pallets are coming through a conveyor, which is at one end of the warehouse, and you are loading on the other end of the warehouse. So there is no way, with this physical construct, there is no way that any slotting would help too much, because any pallet has to travel from one end to the other. We thought about opening a door close to the conveyors, so for some, high volume products, we might just get it from the conveyor and load it from a very closed door. But that was requiring some physical investment, and we put it on hold and decided to test the AGV scenario first, or the ASRS scenario first. So we applied the slotting, but it didn't promise too much because of this physical constraint. From one end to the other, it has to travel all the way. No way other than that.
Cool. I hope that answers your question, Anastasia. Serkan Saran is asking if it's possible to link such models with sales forecasting. Could you extend the model out in that way?
Yes, actually. In fact, we sort of did that because we run this model for several weeks of the year. Some weeks with high demand, some weeks with low demand. And as I also said it here, we could use some random data to simulate the demand as if it's getting higher, getting lower. So indirectly, yes, we did that. In theory and in practice, you may, of course, decide to use it continuously with feeding the forecast data all the time and planning your resource levels ahead in time, planning your rack switch on and off ahead in time. You could do that. It has the infrastructure for that. But in this customer case, we use several sampled weeks to see the effect of high demand, low demand.
It seems like that's going towards a kind of digital twin.
Yes, yes, absolutely, absolutely. The customer also has a digital transformation strategy, and this was sort of a first step, let me say, to digital twin.
Step by step.
Yeah.
Okay. Lee Van Dang is asking, how do we find the best scenario? Because there are many scenarios to test. Do you need to run all of them to be able to compare?
Well, for our simple objective, that's what we did. We did more than this actually, but I am presenting only the reasonable ones. We did this. I think we had one question in the beginning of the Q&A session. We might use optimization. We might use the optimization engine, changing all these, or we might use parameter variation experiment. AnyLogic has all this great stuff there. If you want to test several scenarios, you can leave it to AnyLogic and it can do it for you. That's a very, very cool functionality. In this case, yes, we just run it and watch the outcomes because I wanted to see this as well. This this picture as well for every scenario, because of course you can embed all these constraints into the AnyLogic simulation experiment as well, so it can discard some of the unfeasible solutions. But I just wanted to run it and watch it here, whether everything was working or not. You could do it with AnyLogic experiments.
And perhaps it may be informative if you could, the model, how much of engagement with the model does the customer have? Do they is it just sort of the results that they get, or do they have interaction with the construction of it? And could you give a bit of information on that, please?
Well, we run the models together, the scenarios, and showed them, if you do this, you will get this. If you do that, you will get that. They are not yet using it as a 100% digital twin. They are not using it all the time. They are using it for scenarios at the moment. If they have an idea, and they come back to us. If they have this AS/RS system, if they have this AGV idea, or if they consider building another dock, where should it be? They will come back to us, and I don't have any complaints about that.
Of course. Great stuff. Okay, I believe that wraps up all the questions. Having a look through. All right. So thank you very much, Ali.
Okay.
I believe we've got a couple of minutes before we take the next presentation. So if people have any more questions, then... Oh, actually, Anastasia has come in with one right at the end. She's very pleased with your detailed answer. And did you also try with different locations of docks, or they already exist, so you could only experiment with turning them on or off?
They existed, yes, they existed. In some other project, we also had that idea, but in this particular warehouse, they were already there. But for slotting purposes, we had an idea about opening another dock close to the conveyors, to the other end of the warehouse, which is not yet, justified, let me say. But yes, these were the already operating warehouse with the simulation.
Fantastic. All right. Thank you very much, Ali.
Thank you very much. Thanks, everyone, for listening. Enjoy the rest of the event. Thanks, Gavin.
Yeah, if you go into the platform, I'm sure there'll be more questions to follow up through by direct chat or in some of the roundtable discussions. Hope to see you there.
Okay. My pleasure. Thank you. Thank you, Gavin.
Take care. Bye-bye.